Perhaps the most important special method in Scala is the apply method. It's actually used very broadly through the language. It is kind of what makes it so that they were able to cause an object-oriented language to also be a functional language. So what is the apply method? Well, it's actually something that you've used a lot in different contexts. We could go ahead and we could start a REPL here, and I can show you a use of the apply method. Array 1, 2, 3. Now, you look at that and you're like, I never called it an apply method on that call, but it turns out I did. That was actually short for array.apply 1, 2, 3. As a general rule in Scala, anytime that you have an object, whether it is a singleton object or an instance object, followed by parentheses, that gets expanded out to a call to the apply method. And so if you want to have an object that works as a function, or you wish to have a class whose instances will work as functions, you can define an apply method. Now, this res0 here, we also use the apply method when we do that. So when I index into an array, that's actually short for calling apply. That's actually quite handy for our vectors, because while we can get elements out using x and y, there are certain situations where it would be handy to get things out by an index instead. So index 0 would be x, index 1 would be y, anything else should probably throw an error. So we'll pass in an index as an integer. Each of these elements is a double, and I'm going to use a match because this is a multi-way selection. In the case that we get 0, we're going to return x. In the case where we get 1, we're going to return y. Oops, except the underscore versions are in the mutable. And in the case where we get anything else, I'm going to throw an exception. So we talked about using try-catch for handling exceptions. You can also raise your own exceptions. You can make it so that if something goes wrong, you throw it. And so I am going to throw an index out of bounds exception, and give it a nice error message so that anyone who's working with this knows what went wrong. So the 2D vector was indexed at % or $index, and that way it will throw an exception, and it will probably wind up printing out a stack trace, or the information is available for people to fix this. This exact same apply method will work quite nicely in our mutable vector. Now I could change this so it's underscore x and underscore y. It really shouldn't matter because we have the methods for x and y. The same thing will wind up being returned. And the advantage of this is instead of getting v1.x, I can actually do v1 sub 0. Why is that an advantage? Well, in the case of 2D, it doesn't matter so much, but this would allow me to do a loop through. So I could have this be I, where I goes from 0 to 1 in this case. But we'll see later how we can actually cause it to truly be a function that we can use. Now, this actually leads to something that is a bit subtle in Scala. For the most part, whether you put parentheses on calls has not been significant. So take, for example, read int. In these videos, I have been careful to put, let's go ahead, io.stdin. I'm not going to bother doing an import here. I have been careful to put parentheses there, but it turns out that if I don't put parentheses, not only does it compile just fine, it runs just fine. As a general rule, if you are calling methods in the libraries, things that aren't in the current file, and they don't take arguments, it doesn't matter whether or not you provide the arguments. But as I've said before, it's good to get into the habit of something that causes side effects to have the parentheses, and something that doesn't cause side effects, you can leave them off. The exception to the parentheses not mattering rule, though, is when the parentheses are invoking apply. And so one of the situations where this happens would be if we were going to declare a function. So here's a simple function that we can play with. Actually, let's go ahead and let's do this one in the REPL. So let's move this back up. Okay, and I want to say val f is equal to, and I'm going to make a function that takes no arguments and goes to math.random. Okay. Now, we would invoke this by doing that. As you just saw, since we know about the apply method, what's really going on here is this is calling f.apply. This type here, function 0, it's a function that takes 0 arguments. It has an apply method in it that takes 0 arguments. Now, if I directly call apply this way, it turns out that whether or not I have the parentheses is not significant. But the way we normally call this, when we say f and we put parentheses after it, the parentheses really matter there. If I leave the parentheses off, I am just getting back the function itself. The parentheses are what signify to Scala that we want to call the apply method, and in order to invoke it like a function, we have to call the apply method. So there are certain situations where the parentheses are significant, and it's mainly when they're telling Scala, for example, that you really want to invoke an apply method.